Hello, my name is Maria Del Valle, and this is my research for this summer. And it was about the application of a quantum harmonic oscillator and how it relates to Bitcoin's cryptocurrency. In this project, it is attempted to model long-term behavior of Bitcoin price volatility by using a quantum harmonic oscillator. Let us start by introducing Bitcoin. So Bitcoin's popularity skyrocketed since 2017, and it is due to the safety that it offers its users through blockchain, and it gives investors confidence to trade cryptocurrency. And now, quantum harmonic oscillator. To better understand, think of the motion of a particle oscillating in a well-shaped as a parabola. An easier way to interpret this could be to use egg cartons. Most of us have seen them in person, and even though they are not wells or a perfect parabola, we will assume that they are for this explanation. We will also assume, as seen in the middle picture, that the egg is much smaller and is perfectly capable to roll from one edge to the other. This, in a way, can be better used to understand how the quantum harmonic oscillator would work if we were to see it in these conditions. Now, how are these two subjects related? They seem so far away from one another. But in this study, I aim to find a connection between these two parallel lines that seem to never cross. And now, for the methodology, we started collecting historical data, and it started from 2014 in the left graph, which is the data collected up until July of 2020. The data is imported into a Python code that runs various mathematical and physical equations that attempt to normalize the Bitcoin price behavior and organize the material in a way that it can be visually interpreted. Like it's the probability density, the skew, the Laplace, and the Gaussian, as well as the quantum harmonic oscillator. This information is then collected and analyzed to determine the long-term behavior Bitcoin has had and estimated a potential rise or drop. To estimate the potential rise or drop, the graph on the right is much easier since it is more detailed. It has a more detailed view on statistical data that may help when trading Bitcoin stocks. Now, before we started analyzing that, we had to know if Bitcoin was time dependent or if it behaved in a static way. The question was, how will I determine this? Well, by creating a time lapse of historical data going back 6 years from May of 2014, we can analyze from graph 4 to 9 how there wasn't that much of a change. But on the graph number 8, there was a slight change, and this occurred right around the time of the halving, which is when Bitcoin it halves, it mines it, and this happens every 4 years. But then quickly after, it restored its balance as seen before. So with this, we assume that it was static and not time dependent. Bitcoin is fairly new to the trading market, so this was assumed with 6 years worth of data. Now, in our discussion, well, in the end, the relationship that tied the quantum harmonic oscillator and the economic phenomena was present in the random transactions. And it can be used in the Bitcoin price volatility prediction. Now that we know this relationship, it is for future studies to face the constraints and challenges that come when trying to describe those random values to improve the quantum physics model to cryptocurrency. This research was all done thanks to the US Department of Education grant award, the STEM space. Thank you.